look at a few terms, because, okay, when n is 1, you get pi over 2, and the sine of pi over 2 is 1. And when n is 2, you get 3/2 pi over 2. When n is 3, 6 minus 1 is 5/2 pi, which is 2, 4
That'd be 1.
1.
Yeah.
Uh-huh.
And it just keeps
So what we have here is the nth term test. Limit n approaches infinity, sine 2n minus 1 pi over 2 doesn't equal 0, which implies diverges by the nth term test. So that's what I would have done for that one, if it was me.
I thought because it was sine, that, and all the terms canceled, that it does equal 0 over 2.
That's so interesting you say that. Let me refer you to
That's why I was confused.
page 638 in your book.
Okay.
There's a very cute example on page 638. Does this seem a little chilly in here to you?
Feels good.
No? Oh, it's okay?
Feels
Okay.
good.
Feels a little nippy to me, but all right.
What page?
He get, page 638. Right here, Alex. Oh, Alex, on the front. Page 638. Okay.
I have the old book, remember?
Oh.
It's all right, I'll figure it out.
If you take a conditionally convergent series and you rearrange the terms, you're not guaranteed that the sum's going to come out to be the same amount. What happens here is when we keep adding this, if you stopped at an odd number of terms, you'd get 1 for an answer.
For the first
If you
term.
stopped at an even number, you'd get 0, and so it doesn't add up to 0. I know exactly what you're thinking. You say, but look, if I do them 2 at a time,
I
they ought
understand,
to.
if the last term that you sum is an odd number, then you're gonna have the 1 up front. It's gonna equal everything. But what says that we're following that rule though, instead of adding to an even number?
See that right there?
Yeah.
Look at the limit of the nth term. Does it equal 0? It's either 1 or -1. I don't care whether you do the odd one or the even one.
Right.
It's not 0, is it? It diverges. That's my very favorite, best test.
So when it's like a trigonometry, like sine or cosine with the next one, do you have to like do a couple terms because like the sine of infinity
I do.
is
Well,
weird?
but we never took the sine of infinity.
Yeah, but that's what they wanted to do. I mean, and the limit is, as n approaches infinity of sine 2n.
But even back when we did Calc 1 and looked at the sines and cosines, we usually looked at whether the thing was bounded on the top versus being bounded on the bottom. So I think you have to do some type of reasoning on it. I can't give you a definite on the trigs. I write out some terms and take a look.
Yeah.
Yeah.
Is that sufficient enough for on the test?
What do you mean? It's beautiful.